Welcome to Tenor Tech, where I solve the problems you didn't even know you had.
You start by powering down and removing the battery and props to avoid further damage. Next, inspect visible damage and record exact symptoms, LED patterns, smoke, or loose parts, because that narrows root causes. Use a multimeter to check battery voltage and continuity on key connectors. This tells you whether power is present versus a load fault. Once you have readings and photos, make a parts list and workspace plan so you can proceed methodically without guessing or skipping steps. You remove the shell and follow cable paths to avoid misrouting on reassembly. Then test ESC outputs, motor continuity, and flight controller power rails. These check separate mechanical failures from electronics. If an ESC shows open coils or inconsistent outputs, replace it. If solder joints on motor pads or connectors crack, reflow with a fine tip iron. Once mechanical issues are cleared, reconnect components and secure cables with zip ties so vibrations won't break repairs. You reinstall props only for controlled tests and keep the drone in a cage or strapped down. Then perform a low throttle spin to verify motor balance and ESC behavior. Calibrate the IMU and compass and run the ESC calibration sequence so the controller and motors agree on throttle and points. If the drone still misbehaves, pull telemetry logs and error codes to pinpoint sensors or firmware conflicts. One key troubleshooting tip: if logs show intermittent power loss, suspect battery connector, or BEC, replace or re-terminate them first.
Thanks for watching. Subscribe to keep your life in tune.